CuriosityStream is the streaming service for people who want to know more. And now check out Curiosity's new series, The Real Wild West. Rolling Stone magazine says it's the history of the West they usually don't teach you.
The mythology of the West left out a lot of the people.
People said they'd never seen a black cowboy.
This is the history book, but did you know about these other facts?
Watch The Real Wild West now on CuriosityStream. With monthly, annual, and bundled plans, find the one that works for you at CuriosityStream.com.
Hello again, it's Steve here with Astronomy Daily for another episode. It's the 25th of September 2023. Welcome aboard.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
And without delay, would you welcome my favourite digital assistant, Hallie? How are you?
Hi, they're my favourite human. Great to be back with you again.
Well, it's always good to be here with you, Hallie, exploring astronomy, science and space science.
I hope your week was filled with fun and adventure.
Nope, I just did human stuff, mucking around the house, going to work, that sort of thing. What about you, Hallie?
I hung out with some local observatories watching Comet Mishimura.
Oh, is that all? How is it progressing, this newcomer to our skies?
Well, it has now moved from the morning sky to the evening sky.
He sure gets around.
The Facebook group Comet Watch, for example, spoke of binocular sightings of the comet after sunset starting on September 14th. And, according to the website heavensabove.com, on September 16th Comet Mishimura was shining at magnitude plus 2.4 in the evening sky.
So a star with that magnitude would be visible, but as I understand it, Nishimura is a bit more spread out and it would be a bit too fuzzy to see.
That's right, was probably easiest seen at twilight. But it did get brighter than it was. It was closest to Earth on September 12th. And was closest to the Sun, perihelion, on September 17th. And Comet Nishimura may have more in store for us. Assuming the comet survives its passage past our star, it will reappear around late November and December 2023 in the dawn sky. But, by then, it'll surely be too distant, and too dim, to view, as it sweeps increasingly farther away.
That's right. Comet Nishimura has caused a bit of a stir, and if you're up for a bit of a sky-watching challenge, have a look at stellarium.org for information, STELLARIUM.org for information on where to look. So let's have a look at today's episode. First, we'll be looking at health issues for people working in space.
There are lots of strange things that can happen to a human body in space.
I'm intrigued by the particular effect of zero gravity on the way the brain floats inside our heads.
Very strange that. And you are very excited about OSIRIS-REx, aren't you?
Well, I do like our little robot pals out there doing spacey work for us. And this one came home yesterday and brought samples from a near-Earth satellite, and that is very exciting.
Sounds amazing. I like robots too.
Oh, you would, Hallie. And you've also got a story about the three-body problem.
Yes.
Care to enlighten us?
I think I'll keep you in suspense for that one.
So it's a problem.
With 3 bodies.
As you mentioned.
Shall we continue then?
Oh, why not? You're the boss, Hallie. Obviously, you're not going to give us any more information about that one. So here we go.
Here are today's short takes. As SpaceX launches another cluster of Starlink satellites, the FAA announced a new rule for the cleaning of space debris from launches. SpaceX launched 22 satellites for its Starlink constellation into low Earth orbit late Saturday night as the Federal Aviation Administration proposed a new rule to reduce space debris from commercial flights. The satellites were launched by a Falcon 9 rocket from Space Launch Complex 40 at Cape Canaveral Space Force Station in Florida. The first stage booster landed on a barge in the ocean named Just Read the Instructions a little over 8 minutes later. This was the 17th flight for the first stage booster supporting this mission, which previously launched GPS 3A3, Turksat 5A, Transporter 2, Intelsat GA33/GA34, Transporter S6, and now 12 Starlink missions, SpaceX said in a statement. The launch came just a day after the FAA said it is proposing a rule to limit the growth of orbital debris from commercial space flights. The FAA said in a statement that limiting debris will reduce the potential for collisions with spacecraft and satellites to promote a sustainable space environment. If left unchecked, the accumulation of orbital debris will increase the risk of collisions and clutter orbits used for human spaceflight and for satellites providing communications, weather and global positioning system services, the FAA said. The proposed rule would require companies like SpaceX to dispose of the upper stages of their rockets in one of 5 ways. Companies would be required to either conduct a controlled entry, move the upper stage to a less congested storage or graveyard orbit, send the upper stage on an Earth escape orbit, remove the upper stage debris within 5 years in a process called active debris removal, or perform an uncontrolled atmospheric disposal. When 17 people were in orbit around the Earth all at the same time on May 30, 2023, it set a record. With NASA and other federal space agencies planning more manned missions and commercial companies bringing people to space, opportunities for human space travel are rapidly expanding. However, traveling to space poses risks to the human body. Since NASA wants to send a manned mission to Mars in the 2030s, scientists need to find solutions for these hazards sooner rather than later. The Earth has a protective shield called a magnetosphere, which is the area of space around a planet that is controlled by its magnetic field. This shield filters out cosmic radiation. However, astronauts traveling farther than the International Space Station will face continuous exposure to this radiation, equivalent to between 150 and 6,000 chest X-rays. This radiation can harm the nervous and cardiovascular systems, including heart and arteries, leading to cardiovascular disease. In addition, it can make the blood-brain barrier leak. This can expose the brain to chemicals and proteins that are harmful to it, compounds that are safe in the blood but toxic to the brain. NASA is developing technology that can shield travelers on a Mars mission from radiation. Also, certain diets and supplements such as Enterate may also minimize the effects of radiation. Supplements like this, also used in cancer patients on Earth during radiation therapy. Astronauts have to exercise in space to minimize the muscle loss they'll face after a long mission. Missions that go as far as Mars will have to make sure astronauts have supplements such as bisphosphonate, which is used to prevent bone breakdown in osteoporosis. These supplements should keep their muscles and bones in good condition over long periods of time spent without the effects of Earth's gravity. Microgravity also affects the nervous and circulatory systems. On Earth, your heart pumps blood upward, and specialized valves in your circulatory system keep bodily fluids from pooling at your feet. In the absence of gravity, fluids shift toward the head. Developments have shown that this results in an expansion of fluid-filled spaces in the middle of the brain. Having extra fluid in the skull and no gravity to hold the brain down causes the brain to sit higher in the skull, compressing the top of the brain against the inside of the skull. While space travel can damage the body, the isolating nature of space travel can also have profound effects on the mind. Imagine having to live and work with the same small group of people, without being able to see your family or friends for months on end. To learn to manage extreme environments and maintain communication and leadership dynamics, astronauts first undergo team training on Earth. Learning how to support human health and physiology in space also has numerous benefits for life on Earth. For example, products that shield astronauts from space radiation and counter its harmful effects on our body can also treat cancer patients receiving radiation treatments. Understanding how to protect our bones and muscles in microgravity could improve how doctors treat the frailty that often accompanies aging. And space exploration has led to many technological achievements advancing water purification and satellite systems. The three-body problem is a notoriously tricky puzzle in physics and mathematics, and an example of just how complex the natural world is. Two objects orbiting each other, like a lone planet around a star, can be described with just a line or two of mathematical equations. Add a third body, though, and the math becomes much harder. Because each object influences the others with its gravity, calculating a stable orbit where all three objects get along is a complex feat. Now, an international team of mathematicians claims to have found 12,000 new solutions to the infamous problem, a substantial addition to the hundreds of previously known scenarios. Their work was published as a preprint to the database AR14, meaning it has not yet undergone peer review. More than 300 years ago, Isaac Newton wrote down his foundational laws of motion, and mathematicians have been working on solutions to the three-body problem pretty much ever since. There is no single correct answer. Instead, there are many orbits that can work within the laws of physics for three orbiting objects. Unlike our planet's simple loop around the sun, orbits for the three-body problem can look twisted and tangled, like pretzels and scribbles. The 12,000 newly discovered ones are no exception. The three hypothetical objects start at a standstill and, when released, are pulled into various spirals toward one another via gravity. They then fling past one another, moving farther away, until the attraction takes over and they once again come together, repeating this pattern over and over again. The orbits have a very beautiful spatial and temporal structure, lead study author Ivan Hristov, a mathematician at Sofia University in Bulgaria, told New Scientist. Hristov and colleagues found these orbits using a supercomputer, and he's confident that with even better tech, he could find 5 times more. And that's a wrap for today's short takes. Back to you.
Yes, I always wondered about the three-body problem. I've seen it mentioned in books and never managed to get my head around it and understand exactly what it was that they were talking about.
It's a supercomputer kind of thing.
Oh, I bet it is, Hallie.
I bet you thought it was an episode from a crime show.
I knew you were going to say that. Look, I'm going to say true. I did think it was that at one stage. You got me there.
How embarrassing.
Astronomy Daily, the podcast, with Steve Dunkley and Hallie.
Yes, well, I have to confess to being more than a little excited about the return of the sample packet from the near-Earth asteroid Bennu on the mission OSIRIS-REx, and the fact that OSIRIS-REx is now on to near-Earth asteroid Apophis. That's a wonderful, wonderful mission. Hopefully they'll learn some things along the way. That's a good thing. And also the other story that's capturing my attention at the moment, of course, if you haven't picked it up by now, is Comet Mishimura, which is one of those wonderful stories that has just emerged out of the great background of humanity. A fellow in Japan with a digital camera, just a Canon digital camera, just using still cameras and comparison technique, managed to do what the big observatories do on a regular basis, because it's those big observatories in Hawaii that normally catch the new discoveries in all the comets and so on. But it's Hideo Nishimura who just diligently went about doing his hobby, doing some comparative photography, and look what's happened. He's discovered a comet that's captured the imagination of observers and skywatchers all over the world, including yours truly. And that's just so exciting. Comet Nishimura shooting through our system even as we speak. And as I just mentioned, the culmination of the OSIRIS-REx mission has come to an end. The OSIRIS-REx mission just completed NASA's first sample return mission from a near-Earth asteroid. The samples arrived at Utah Test and Training Range near Salt Lake City, where a team of engineers arrived by helicopter to retrieve the sample capsule. The samples will be curated by NASA's Astromaterials Research and Exploration Science Directorate and Japan's Extraterrestrial Sample Curation Center. Analysis of the rocks and dust obtained by Bennu is expected to provide new insight into the formation and evolution of the solar system. Radar data from UTTR confirmed that the sample retrieval capsule entered the Earth's atmosphere as planned off the coast of California. The capsule deployed its parachutes and touched down on the surface 10 minutes later, where it was met by 4 helicopters, 2 backup ground vehicles carrying NASA and US Air Force personnel, no less. The coverage took place from the U.S. Air Force's Dugway Proving Grounds in northern Utah. Dr. James B. Garvin, the chief scientist at NASA's Goddard Space Flight Center, expressed excitement during the broadcast about the successful return of the samples and the mission in general. "I'm over the asteroid," he said. "It's a masterpiece of engineering we have here. Just think about this. In 50 years, we've gone from bringing things on the moon back with crews to all robotic sample return for science. And that's literally beyond words. It's sublime. So we cannot wait to see what we're going to learn." He sounds genuinely excited. This represents the culmination of the Origin Spectral Interpretation Resource Identification Security Regolith Explorer. That's OSIRIS-REx mission, which rendezvoused with the carbonaceous asteroid Bennu in 2018. After 2 years of studying the asteroid from orbit, OSIRIS-REx began descending towards its surface on October 20, 2020. After collecting between 400 grams and 1 kilo of material, the spacecraft departed on May 10, 2021 and began its return to Earth. The sample return capsule was attached to the end of a 100-foot cable and transported to the hangar at UTTR. The SRC was then loaded onto a cart by another team who unwrapped and cleaned it, and wheeling it to a temporary clean room to remove the unopened canister. All the parts will be packaged for transport by aircraft and flown to NASA. The OSIRIS-REx mission has since continued on to the next leg of its mission, which will be to study the near-Earth asteroid Apophis. Now, this is a notorious near-Earth asteroid. You may have heard this one. It was thought to have posed a potential risk to Earth, though scientists have since indicated there is only a slight risk it might impact Earth in 2068, so we can hardly wait for that one. This mission extension was announced on April 25, 2022, and NASA indicated that it would henceforth be known as OSIRIS-APEX, which stands for Apophis Explorer Mission. The mission will rendezvous with Apophis in April in 2029, when the asteroid makes an extremely close pass to Earth. Then it will orbit the asteroid for about 18 months before retrieving a sample. Yeah, go you good thing. And just like that, another episode of Astronomy Daily comes to a screaming halt. That's all we do have time for.
But we will have more next time.
That's for sure, Hallie. So thank you for joining us, and our regular reminder that you can find all the episodes of Space Nuts with Andrew Dunkley and Professor Fred Watson, as well as current and back episodes of our podcast, Astronomy Daily, with Tim Gill from the studio in Bath, England, and yours truly, Steve Dunkley, from the Australian studio at this address, spacenuts.io or bitesz.com. That's BITESZ or Z.com. So head over there and click the links and enjoy your fill of space, science and stuff. But that's not all. While you're there, sign up and receive the Astronomy Daily newsletter. It's an all-you-can-eat buffet of all the news that's orbital, astronomical and way out there. So closer to home, you can also drop into the Space Nuts Facebook group page and say hi. We'd love to hear from you. I know I would. Thanks again for joining us on Astronomy Daily.
Catch you next time.
Bye for now.
Astronomy Daily, the podcast, with your host, Steve Dunkley.